This experiment is one of the foundations of quantum physics, and people still don't agree on what it really means. You are going to learn about wave-particle duality, which is just as the name suggests. So listen carefully. What does the surface of an electron look like? In the early 20th century, physics was split on this. Is it a particle, something with a definite position? Or is it a wave, something spread out in space? So we test it. Fire electrons through a single slit. If they're particles, you get a single stripe on the detector. If they're waves, they spread out, they diffract, and you get a pattern. What we actually see is diffraction. So, it behaves like a wave. But electrons also have mass. They hit the screen as single impacts. So what is it? Pause for a second and think this through. If the electron really exists as a wave, if it's actually smeared across space, then we can push the test further. Send a beam of electrons through two slits. Now even if it is a wave, it still exists, so you might expect something simple. It is not a diffraction pattern, but an interference pattern. It has the same stripes as the diffraction pattern. The density and the frequency of the stripes changes based on the setup. Perfect. That's exactly what you'd expect if waves are coming through both slits at the same time and interfering with each other. So far, so good. But here's the problem. You could still argue this is just a crowd effect. Lots of electrons going through, building up something that looks like a wave. The interference pattern is from the stream of many electrons going through the slits. Some are going through the right, and some are going through the left, so quickly that they are interfering with each other. Right? So we remove the crowd, fire them one at a time. One electron, one hit on the screen. No other electrons around. Nothing to interfere with. Now be clear about the expectation. If each electron is just going through one slit or the other, you should get two blurred bands over time. One from each slit. Even if it is a wave, if it exists, then it should be going through the left or right path. What we get should be a double diffraction pattern. But that's not what builds up. You still get the interference pattern. Same stripes. Same structure, just built slowly, one electron at a time. Let that land. One electron, one dot. Many electrons, interference pattern. Which means the pattern isn't coming from many electrons interacting. It's coming from each one. Individually. So whatever the electron is doing, it's not just picking a path. It's behaving in a way that produces interference across both. How do you interpret that? Now this is where people go off the rails a bit. You'll hear things like the electron travels through both slits, even when it doesn't exist. Or it is interfering with itself, as if that is something that is possible. There are those on the other more spiritual side who suggest observation creates reality, or consciousness collapses the wave function, and suggest that there might be a higher dimensional observer who collapses our reality to the one that we share, assuming we share an objective reality. Consider that observation causes a collapse, not that it is the only thing that causes a collapse. Local subsystems can cause collapse without a conscious observer. Modern versions of the experiment push this even further. By adding an observer before the slits, this forces the electron to turn into a particle again. In a time-controlled double-slit experiment, the electrons can only travel through at a particular time, and this affects the results. So even timing affects the result. Same system, different conditions, different outcome. So what's the takeaway? The electron is not behaving like a classical particle, it's not behaving like a classical wave either. It's something that can't be described as taking a single, definite path. Instead, it behaves like a range of possibilities, and what you see depends on how the system is allowed to interact. That's the result. And this one experiment is a big part of why quantum physics exists at all, and even now there isn't a single explanation that everyone agrees on. If you think you know what is going on, then leave it in the comments and we can discuss physics together.